In this example, we're going to talk about partial fractions with a repeated linear factor. For example, if we have a rational function that looks like this one, 2x plus 3 over x minus 5 squared. Is there a partial fractions decomposition of this expression? And the answer is yes. The decomposition looks like the following. If the degree of p of x is less than n, then we use in this formula p of x over ax plus b, everything to the n, is equal to some constant c1 over ax plus b plus c2 ax plus b squared plus all the way to cn over ax plus b to the n. And of course we need to determine the constant c1, c2 all the way to cn. Now let's do example 4. We try to find the integral of 5x squared plus 20x plus 6 divided it's over x cubed plus 2x squared plus x dx. Like the previous examples, we're gonna try to factor the denominator. And by the way, the degree of the top is 2, the degree of the bottom is 3, so that's okay. So the degree of the px is less than n. Okay, so let's factor the denominator. So we can factor the x. So it will be x squared plus 2x plus 1, 5x squared plus 20x plus 6. Now let's factor the denominator more. This is just x plus 1 squared, so which is a repeated linear factor. 5x squared plus 20x plus 6. Now this is going to be a over x plus, since x plus 1 is a repeating factor, so we need to do b over x plus 1 plus c over x plus 1 squared. Let's go back here. This is 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Now this is equal a over x plus b over x plus 1 plus c over x plus 1 squared. Of course the common denominator is x times x plus 1 squared. So this is missing x plus 1 squared for the common denominator. So since we multiply the denominator by x plus 1 squared, we multiply the numerator also by x plus 1 squared plus b over x plus 1. Now this is missing x, so we multiply the top by x, and this is missing times another x plus 1. So it's x plus 1 squared, so I multiply the top also by x plus 1. And then for the last term, it's missing an x in the denominator, so we multiply the top by x. Now let's rewrite this as 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Now the numerator, which is 5x squared plus 20x plus 6 on the left side, is equal to the sum of the numerators from the right side. So this is ax plus 1 squared plus bx x plus 1 plus cx. Now we know that this equation is true for all x. So let's pick an x that makes at least two terms go to 0. Of course, you can see here if we pick x equal -1, left side will be 5 times -1 squared plus 20 -1 plus 6 is equal. Now, once we plug -1, this will go to 0 plus b -1. -1 plus 1 is 0, so this will go to 0 plus c times -1. Now if we add the left will be 9. Right side c times -1 is negative c. Actually negative c. Actually the left side is -20 plus 5, so it's a -9 is equal negative c, which means c is equal 9. So here's our first constant. Now if we look at the right side of the equation, if we plug in 0 for x, then the second term and the third term will go to 0. And this way it's easy to find a. So let's do that. Let x equal 0. Now this is 5 times 0 squared plus 20 times 0 plus 6. It's going to be a 0 plus 1 squared plus b times 0, 0 plus 1. So this is second term goes to 0 plus c times 0, and this is going also to 0. If we add, so left side it's easy, this is 6, and then a times 1 is a, so a is equal 6. Now unfortunately notice that there is no choice of x that will make the two terms containing a and c both 0 without also making the term containing b 0. However, we can pick any value for x, it will work. Well, let's pick an easy one, for example x equal 1, and let's plug that in. If we do that, we get 5 times 1 squared plus 20 times 1 plus 6 is equal a 1 plus 1 squared plus b times 1 plus 1 plus c times 1. Now if we add the numbers on the left side, 5 plus 20 plus 6 is 31, and then 1 plus 1 is 2, 2 squared is 4, so this is 4a plus 1 plus 1 is 2, so 2b plus c. Now 31 is equal, now I know a is equal 6, so 4 times 6, and I know that b is equal, what is b equal to? Actually the b is what we're looking for, and c is equal 9. Now let's do the integral. This is 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx, and this is equal integral 6 over x, 6 is the value of a, minus b over x plus 1, but b happens to be -1, so -1 over x plus 1 plus c is 9 over x plus 1 squared, everything dx. Now this is equal to 6 integral of 1 over x dx minus integral of 1 over x plus 1 dx plus 9 integral of x plus 1 and negative 2 dx. So let's do the last integral. We need to use substitution. So let u equal x plus 1. Therefore du is equal dx. Now let's call this integral to be 2. So 2 is equal integral of u negative 2 du, which is u negative 2 plus 1 is negative 1 over negative 1, which is equal negative 1 over u. Let's substitute back x plus 1 into u, so negative 1 over x plus 1. Now let's rewrite all this stuff. This is equal to 6. Integral of 1 over x dx is ln the absolute value of x. Integral of 1 over x plus 1, that's an easy one also, ln of x plus 1 plus 9, and the integral of x plus 1 negative 2 dx, we just said it's a negative 1 over x plus 1 plus a constant c. And we're done from this example.